Every picture of the solar system you have ever carried in your mind is incomplete, not because the planets are wrong and not because the science is outdated, but because the image always ends far too early. Since childhood, you have been shown the same familiar diagram again and again. A glowing yellow sun sits at the center. Mercury circles close beside it. Venus follows quietly farther out. Then Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. Maybe Pluto appears as a tiny frozen dot near the edge, before the picture fades into darkness. The solar system is finished. At least that is what it feels like. That image appears everywhere. In classrooms, textbooks, documentaries, museum posters, and animations designed to explain our place in the universe. And because you have seen it so many times, your brain slowly accepts an illusion without ever realizing it. The illusion is not that the planets exist. They do. The illusion is that the planets are the solar system. But they are not. Not even close. Because beyond Neptune, beyond Pluto, beyond every spacecraft humanity has ever launched, lies a structure so enormous that it makes the entire planetary region look microscopic by comparison. A hidden sphere of frozen darkness stretching outward for distances so extreme that sunlight itself takes more than a year to cross it. A region so vast that the nearest star no longer feels impossibly far away. This is the Oort Cloud. And if modern scientific models are correct, then the real solar system may extend nearly halfway to another star. That single fact changes the scale of the solar system completely. Because the planets you know may occupy only a microscopic fraction of the sun's true domain. Tonight, we are going to leave the familiar solar system behind, not by traveling to another galaxy or crossing into some distant nebula, but by continuing outward long after every diagram you have ever seen tells you to stop, because the largest part of our cosmic neighborhood was never the planets. It was the darkness surrounding them. And almost nobody truly understands how enormous that darkness really is. Close your eyes for a moment and picture the solar system. You already know what appears in your mind: a flat disk, bright planets, clean circular orbits surrounding a warm central star, order, structure. Something compact enough to fit comfortably inside human imagination. So now imagine moving outward. Past Neptune, past Pluto, past the last icy fragments drifting at the edge of sunlight. Keep going. The planets disappear behind you. The sun shrinks smaller and smaller until it becomes only another bright point among countless stars. Days pass, then weeks, then months, and still you have not left the solar system. This is the part that breaks human intuition, because the human brain was never designed to understand distances like these. Your ancestors evolved to measure rivers, mountains, storms, and forests. They never needed to emotionally process structures measured in light years. So when people hear numbers like 100,000 astronomical units, the mind quietly translates them into something vague. Very far. But the Oort Cloud is not merely very far. It changes the meaning of the solar system itself. The planets are not the system. They are only the tiny illuminated center of something vastly larger. Imagine drawing a map of Earth, but only including your living room. The couch is accurate, the walls are accurate, the proportions are technically correct, but the map creates a false understanding of reality. It quietly convinces you that one room is the entire world. That is what most diagrams of the solar system do. They are not wrong. They are incomplete. And what they leave out is almost everything. Far beyond the orbit of Neptune exists a region where the sun no longer feels like a sun at all. Only a star, a brilliant point suspended inside a sea of darkness. Out there, sunlight is too weak to warm anything, too weak to create day, too weak to illuminate the frozen objects drifting silently through the void. Trillions of icy bodies may exist in this region, preserved almost perfectly since the birth of the solar system more than 4.5 billion years ago. Some may orbit the sun only once every few million years. Some may never approach the planets at all. And some are so distant that if humanity launched a spacecraft toward them today, entire civilizations could rise and disappear before the probe ever arrived. And yet, every one of those distant frozen objects still belongs to the sun. Still belongs to the solar system. And the strangest part is, humanity has never actually seen this structure directly. No astronaut has visited it. No telescope has photographed it. No spacecraft has ever reached it. In the entire history of astronomy, not a single confirmed image of the Oort Cloud has ever been captured. And yet scientists are almost certain it exists. Because for centuries, the evidence has been falling into our skies. Comets, ancient objects emerging from darkness so distant that some of them began their journey toward the sun before human civilization even existed. These comets do not arrive from a flat plane like the planets. They come from every direction. Above us, below us, across every region of the sky. And their strange trajectories reveal something extraordinary. Somewhere far beyond the known planets, a vast spherical reservoir of icy bodies surrounds the solar system itself. Every comet is a clue. Every orbit points towards something hidden in the darkness beyond Pluto. A structure so enormous that when astronomers finally understood its possible scale, the familiar picture of the solar system quietly collapsed. And later in this journey, you will realize something even stranger. The farther outward you travel, the less the solar system resembles a home. It becomes colder, darker, quieter, until eventually the sun itself loses its identity. Imagine standing on an object near the outer edge of the Oort Cloud. Above you stretches a sky filled with stars. And somewhere among them is the sun, bright, sharp, beautiful. But no brighter than the stars we see from Earth tonight. You could cover it with your fingertip. The star that created Earth, oceans, forests, and human history would appear reduced to a distant point of light in the darkness. And still, you would not yet have left the solar system. That realization changes everything. Because it means the solar system is not a compact arrangement of planets orbiting close to the sun. It is an enormous gravitational territory extending deep into interstellar space, a frozen shell surrounding us in every direction. Invisible, silent, almost unimaginably empty. But real. Tonight, we are going to rebuild that picture from the beginning. We are going to travel outward step by step. From Earth to Neptune, beyond Pluto, through the Kuiper Belt, past the path of Voyager, and finally into the immense frozen sphere surrounding our star. By the end of this journey, the solar system you grew up imagining will feel impossibly small. Because the planets are not the main feature of our cosmic neighborhood. They are only the warm center of a structure dominated by darkness. And that darkness stretches farther than most people will ever truly comprehend. For most of human history, the solar system felt understandable. Not small exactly, but contained. A family of worlds orbiting a single star. A bright center surrounded by planets moving through darkness in predictable paths. Even when astronomers discovered new moons, new asteroids, and distant dwarf planets, the overall picture still felt manageable, ordered, finite. But the deeper scientists looked into space, the more unsettling a realization began to emerge. The planets were not the system. They were only the beginning of it. And to understand why, we need to leave Earth behind step by step, exactly the way astronomers themselves slowly uncovered the true scale of the Sun's domain. Start at Earth. Right now, you are orbiting the Sun at roughly 93 million miles away. This distance is so important to astronomy that scientists created an entirely new unit just to measure it. One astronomical unit, 1 AU. That becomes the ruler for everything else. Light from the Sun reaches Earth in a little over 8 minutes. Every sunrise you have ever seen began its journey across space 8 minutes earlier. The warmth on your skin, the daylight filling cities and oceans, all of it traveled across 93 million miles of emptiness before arriving here. And yet, on the scale of the real solar system, Earth is still almost touching the Sun. Mercury circles even closer, Venus slightly farther out, then Earth, then Mars. These inner planets feel separated when shown in textbooks, but in reality, they occupy a surprisingly compact region around the Sun. If the Sun were the size of a large front door, the entire inner solar system would fit comfortably inside a small neighborhood. Then comes the asteroid belt. Movies often portray it as a crowded field of tumbling rocks where spacecraft must dodge obstacles every few seconds. Reality is quieter, much quieter. Most asteroids are separated by enormous distances. A spacecraft could pass through the asteroid belt without ever seeing another asteroid nearby. The belt only appears dense in diagrams because otherwise the asteroids would be too tiny to notice. This is your first clue that space itself is the real dominant feature of the solar system. Not planets, not moons, emptiness. And beyond that emptiness waits Jupiter. Jupiter changes everything. At over 11 times wider than Earth, and containing more than twice the mass of every other planet combined, Jupiter is less like a planet and more like a failed star. Its gravity shaped the architecture of the solar system itself. It redirected asteroids, captured moons, disturbed comets, possibly even protected Earth from catastrophic impacts countless times across history. Standing near Jupiter would feel like standing beside a cosmic machine, powerful enough to rearrange worlds. And yet even Jupiter occupies only a tiny fraction of the Sun's true territory. Beyond Jupiter lies Saturn with its vast rings suspended like frozen blades in darkness. Then Uranus, then Neptune. Neptune is important because this is where most human intuition quietly stops. 30 astronomical units from the Sun. That number sounds large, and it is. Sunlight reaching Neptune is already 900 times weaker than the sunlight touching Earth. Noon on Neptune would feel dimmer than twilight here. The Sun itself would appear tiny in the sky, still bright but no longer dominant. Neptune takes 165 Earth years to complete a single orbit. Think about that for a moment. The last time Neptune occupied the position it is in today, human beings had not invented airplanes. Entire nations looked different. Electricity was still transforming civilization. Every photograph, every film, every rocket launch in human history has happened during less than a single Neptunian year. And still, Neptune is nowhere near the edge of the solar system. This is where the illusion begins. Because almost every diagram ever shown to you quietly implies something false. Once Neptune appears near the edge of the image, your brain naturally assumes the system is nearly over. Maybe a few icy leftovers remain beyond it, then emptiness, then the stars. But space does not work that way. The sun's gravity does not suddenly stop after the last planet. In fact, beyond Neptune is where the solar system starts becoming truly enormous. Past Neptune lies the Kuiper Belt, a broad region filled with frozen remnants left over from the birth of the solar system itself. Pluto lives here, along with thousands of other icy worlds drifting in darkness. Some are mountains of frozen nitrogen and methane. Others are ancient shattered fragments that have barely changed in over 4 billion years. When Pluto was discovered in 1930, many people imagined it as the lonely final planet at the edge of everything. But Pluto was not the edge. It was the first sign that something much larger waited beyond. Because the Kuiper Belt stretches outward for billions of additional miles. And even that region is still relatively close to the Sun. This is difficult for the human mind to process. Distances have already become so extreme that ordinary language begins breaking down. Numbers stop feeling meaningful. So let's slow the scale down. Imagine shrinking the Sun to the size of a basketball. At that scale, Earth would orbit roughly 80 feet away. Neptune would be almost half a mile from the basketball. That already sounds enormous. But the Kuiper Belt would continue farther beyond that. And the true outer boundary of the solar system. It would not fit inside the city anymore. That is the part no classroom model ever shows you. Because the real scale becomes too large to demonstrate physically. Past Pluto and the Kuiper Belt, the solar system grows darker and stranger. Objects begin following bizarre elongated paths, unlike the nearly circular orbits of the planets. Some travel hundreds of astronomical units away before slowly falling back inward again. One of them is Sedna. Sedna is one of the strangest worlds humanity has ever discovered. At its closest approach, it still remains far beyond Pluto. At its farthest distance, it travels so unbelievably far from the Sun that its orbit takes around 11,000 years to complete. When Sedna was last near its current position, human civilization did not yet exist. Agriculture had not begun. Cities had not been built. Written language had not appeared. Sedna drifts through darkness on timescales larger than human history itself. And what makes Sedna truly unsettling is this. Scientists still do not fully understand how it ended up there. Neptune cannot explain its orbit. The known planets are too weak at that distance. Something else shaped it long ago, possibly a passing star, possibly the gravity of the Milky Way itself, maybe even events from the Sun's birth cluster billions of years ago. Sedna exists in a region where the boundary between the solar system and interstellar space starts becoming blurry. And that boundary is much farther away than most people realize. Because eventually you reach another famous marker in space. The heliopause. This is the point where the solar wind, charged particles streaming outward from the Sun, finally weakens enough for interstellar space to push back. NASA's Voyager 1 spacecraft crossed this boundary in 2012. Headlines around the world celebrated the moment humanity had left the solar system. But that statement was deeply misleading. Voyager did enter interstellar space in one sense. It moved beyond the Sun's bubble of plasma and solar particles, but it did not leave the Sun's gravitational territory. Not even remotely. Imagine walking out of your house and claiming you left your country. That is roughly how inaccurate those headlines were. because gravity reaches incomparably farther than sunlight or solar wind. Voyager crossed the heliopause at around 120 astronomical units. The Oort Cloud may extend to 100,000. That difference is almost impossible to emotionally grasp. Voyager 1, the most distant object humanity has ever created, has been traveling since 1977. Nearly half a century. And during all that time, it has only traveled a microscopic fraction of the distance needed to cross the Sun's full gravitational domain. At its current speed, Voyager would need roughly 30,000 years to travel through the outer reaches of the Oort Cloud. 30,000 years. When Voyager finally exits the Sun's outer territory, every civilization alive today will be gone, every skyscraper reduced to dust, every language transformed. Human history itself may look completely unrecognizable. That is the size of the structure surrounding us. And we have not even reached the Oort Cloud yet. Now the scale starts becoming truly disturbing. Because beyond the heliopause, beyond Voyager, beyond the last visible remnants of sunlight, scientists believe trillions of frozen objects surround the Sun in every direction. Not in a flat disk like the planets. A sphere, a colossal shell stretching outward into interstellar darkness. The Oort Cloud, and the evidence for its existence arrives in our skies all the time. Comets, not ordinary short-period comets that return every few decades, but ancient long-period comets arriving from every direction imaginable, above the solar system, below it, sideways across it. These comets behave differently from planets because they come from somewhere fundamentally different. A spherical reservoir, a hidden outer kingdom of the Sun. Every one of those comets is like a message from the edge of the solar system. A frozen survivor from the earliest era of planetary formation. Some of them began falling toward the Sun thousands of years ago when mammoths still walked Earth. Others may have spent millions of years drifting in total darkness before gravity nudged them inward. And their existence reveals something extraordinary. The solar system was never a compact arrangement of planets. It is an immense gravitational empire extending deep into the void between stars. The planets are only the warm, illuminated core. Everything else is darkness. For thousands of years, comets terrified humanity. Civilizations watched glowing objects suddenly appear in the sky without warning, burn brighter night after night, and then slowly disappear back into darkness. Kings treated them as omens. Armies feared them before wars. Entire cultures believed they announced catastrophe, plague, or the death of rulers. And honestly, from Earth, comets do look unnatural. Unlike planets, they do not move with calm predictability. They arrive unexpectedly. Some grow enormous tails stretching across the sky. Others appear once and never return within a human lifetime. They feel less like stable worlds and more like intruders entering the solar system from somewhere unknown. For centuries, nobody understood where they came from. But eventually, astronomers began tracking them carefully. And what they discovered would quietly destroy humanity's old picture of the solar system forever. The first major clue came from orbital mechanics. Once scientists learned how to calculate comet trajectories, they noticed something strange. Some comets followed relatively short orbits. Halley's Comet, for example, returns roughly every 76 years. Its path is stable and predictable. Astronomers can calculate exactly when it will return again. These became known as short-period comets. Most of them orbit roughly along the same flat plane as the planets, which immediately suggested they originated somewhere near the planetary region itself. Today, scientists believe many of them come from the Kuiper Belt and the scattered disk beyond Neptune. But another category of comet behaved completely differently. Long-period comets. These objects did not return every few decades. Some required thousands of years to complete a single orbit. Others needed tens of thousands. A few appeared to require hundreds of thousands or even millions of years before returning again. And unlike the planets, they did not arrive from one organized direction. They came from everywhere. Above the solar system, below it, from angles completely disconnected from the planetary plane. This detail mattered more than anyone initially realized. Because if these comets originated from a flat structure like the planets, their orbits should mostly align in the same general direction. That is exactly what happens with planets and many short-period comets. Gravity naturally organizes objects into disks over time. But long-period comets ignored that pattern completely. Their trajectories looked chaotic, random, almost spherical. And once astronomers plotted enough of them together, the implication became impossible to ignore. Something enormous surrounded the solar system in every direction. Not a ring, not a disk, a shell. This was the first moment humanity began realizing the solar system might not truly end where the planets stopped. But the deeper scientists looked into the numbers, the stranger the situation became. Because these comets were not simply arriving from far away. They were arriving from distances so extreme that the human brain struggles to emotionally process them. Take a comet with an orbital period of 50,000 years. That means the last time it visited the inner solar system, human civilization barely existed. Ancient empires had not yet risen. Entire languages spoken today would have sounded completely alien. Human history itself occupied only a tiny fraction of the comet's orbit. And yet eventually, after tens of thousands of years drifting in darkness, gravity slowly pulled it back toward the sun. Imagine that journey. For thousands upon thousands of years, the comet moves through nearly perfect blackness. The sun ahead is nothing more than a bright star among countless others. No warmth touches its surface. No nearby planets illuminate the void around it. It drifts silently through cold older than human civilization itself. Then gradually, after millennia of falling inward, the sun begins growing brighter. Jupiter appears. Saturn, the inner planets. Finally, the comet races toward the sun in a brilliant eruption of vaporizing ice, becoming visible from Earth for a few brief weeks, before disappearing again into darkness for another geological stretch of time. Comets are not temporary visitors. They are survivors from a region so distant that human history feels microscopic compared to their journeys. And every one of those journeys pointed toward the same conclusion. A vast reservoir existed far beyond Neptune. The question was, how far? That answer began emerging in the early 20th century. In 1950, Dutch astronomer Jan Oort studied the orbital data of long-period comets and noticed a pattern hiding inside their trajectories. When he calculated the farthest points of their orbits, the aphelia, many clustered at astonishing distances from the sun. Tens of thousands of astronomical units. Not hundreds, not thousands, tens of thousands. Oort realized something profound. The comets were not being created randomly. They were falling inward from a gigantic outer reservoir surrounding the solar system itself. And this reservoir had to be enormous, not only because of its size, but because of its population. Comets gradually die. Every close pass near the Sun vaporizes some of their ice. Over enough orbits, they either disintegrate completely or get ejected from the solar system through gravitational interactions with planets like Jupiter. This means the visible comets humanity sees today cannot survive forever. And yet new long-period comets keep arriving. Century after century, millennium after millennium, which means something out there is continuously replacing them. A hidden supply, a cosmic storage vault surrounding the Sun in darkness. This became the foundation of what we now call the Oort Cloud. And the implications were staggering, because according to the calculations, the outer edge of this structure might extend nearly halfway to the nearest star. That single realization completely changes the meaning of the phrase solar system. Most people unconsciously imagine the solar system as a local neighborhood surrounding the Sun, a compact family of planets separated from other stars by enormous empty gaps. But the Oort Cloud destroys that image. Because the Sun's gravitational influence does not stop where sunlight fades. Gravity reaches vastly farther. Imagine standing near the outer edge of the Oort Cloud. The Sun would still technically own you gravitationally. You would still orbit it. But visually, the Sun would no longer feel like a sun at all. It would look like an unusually bright star. That is how enormous this structure truly is. And yet something even stranger happens at those distances. The galaxy itself begins interfering with the solar system. This is where the story becomes almost surreal. Because objects in the outer Oort Cloud are so distant from the Sun that nearby stars can disturb their orbits. Not dramatically, not like collisions in science fiction movies, just subtle gravitational nudges, tiny changes. But over millions of years, tiny changes become enormous consequences. A passing star moving through the Milky Way can slightly alter the orbit of a frozen Oort Cloud object, changing its path just enough to send it falling inward toward the Sun. This means some of the comets humanity sees from Earth may have started their journey because another star passed nearby millions of years ago. Think about that. A distant stellar encounter occurring before human beings even evolved may still influence the night sky we see today. The outer solar system is not isolated from the galaxy. It blends into it. And the farther outward scientists looked, the more unsettling the scale became. Because eventually astronomers realized something extraordinary. The Oort Cloud may contain trillions of objects. Trillions, not planets, not giant worlds. Mostly frozen remnants left over from the birth of the solar system itself. Ancient icy bodies preserved in darkness for over 4.5 billion years. Some may only be a few miles wide. Others could be significantly larger. But together they form one of the largest structures associated with the Sun. And yet, despite containing trillions of objects, the Oort Cloud is still almost unimaginably empty. This sounds contradictory at first. How can trillions of objects exist without creating a crowded environment? Because the structure itself is so incomprehensibly vast that even trillions of bodies become diluted across impossible distances. two neighboring Oort Cloud objects may still be separated by billions of miles. An observer standing on one of them would likely see nothing nearby at all. No glowing swarm, no crowded field of icy debris, just darkness, stars, and perhaps one unusually bright point in the distance. The Sun. This is why the Oort Cloud has never been photographed directly. Not because scientists doubt it exists, but because its members are too small, too dark, and too widely separated to observe easily. The Oort Cloud hides behind scale itself. That is what makes it so psychologically disturbing. Human beings evolved assuming large structures should be visible. Mountains dominate landscapes, oceans dominate planets, galaxies blaze with billions of stars. But the largest part of our own solar system may be almost completely invisible. A colossal sphere surrounding us in silence, undetectable to human eyes, and yet constantly revealing itself through comets. Every long-period comet entering the inner solar system is evidence that the Oort Cloud still exists. Still active, still surrounding us, still sending frozen messengers inward from distances almost impossible to comprehend. And now another realization begins emerging. If the Oort Cloud extends halfway to another star, then where does one solar system truly end and another begin? Because gravity does not create clean borders. The outer edge of the Sun's influence slowly weakens into the larger gravitational field of the Milky Way itself. The farther outward you travel, the more the distinction between solar system and interstellar space begins collapsing. The Oort Cloud is not simply the edge of the solar system. It is the transition zone between stars. A frozen frontier where the Sun gradually stops behaving like the dominant object in space. And this raises an unsettling possibility. Some objects drifting through the outer Oort Cloud today may not have formed around our Sun at all. They may have been captured from other stars billions of years ago, when the Sun formed inside a dense stellar nursery. In other words, parts of the outer solar system may literally be alien. That possibility remained mostly theoretical for decades, until humanity discovered something moving through the solar system that did not belong here at all. Something from interstellar space itself. And once astronomers saw it, the idea of the Oort Cloud suddenly became even stranger than anyone expected. For most of modern history, astronomers assumed the solar system was isolated. Not completely separated from the galaxy, of course. Everyone understood stars existed nearby. Scientists knew the Milky Way surrounded us, but there was still an invisible psychological boundary in the human mind, a sense that the solar system was its own contained environment. Objects belonged either here or somewhere else. Comets belonged to the Sun. Asteroids belonged to the Sun. Planets belonged to the Sun. And the vast darkness between stars felt mostly empty. The Oort Cloud already complicated that picture by extending the Sun's influence deep into interstellar space. But even then, most people still imagine the solar system as fundamentally self-contained. Then, in October 2017, astronomers noticed something moving through the inner solar system that shattered that assumption forever. At first, it did not seem extraordinary. A telescope in Hawaii detected a faint object traveling rapidly against the background stars. Discoveries like this happen constantly. New asteroids and comets are found every week. Initially, the object received only a routine designation. But within days, astronomers realized something was wrong. Its speed was too high. Its trajectory was too strange. And most importantly, the sun could not hold on to it. Every normal object in the solar system follows an orbit bound by the sun's gravity. Even extremely elongated comet orbits still curve back eventually. They remain connected to the solar system like stretched elastic bands. This object did not. Its path was hyperbolic. Open, unbound. It was not orbiting the sun at all. It was passing through. For the first time in recorded history, humanity had discovered a confirmed interstellar object entering the solar system from another star. Its name became Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first. And almost immediately, Oumuamua became one of the most mysterious objects ever discovered. Because nothing about it behaved normally. First came its shape. As astronomers tracked the amount of sunlight reflecting from the object, they noticed its brightness changed dramatically over time. The simplest explanation was shocking. Oumuamua appeared extremely elongated, possibly shaped like a cigar or pancake, unlike anything previously observed in the solar system. Some estimates suggested it may have been several times longer than it was wide. No known asteroid looked like that. No known comet looked like that either. Then came the second mystery. As Oumuamua traveled away from the sun, astronomers detected a tiny acceleration in its motion. Something was pushing it slightly faster than gravity alone could explain. Normally, this happens with comets because sunlight heats their ice, creating jets of gas that act like miniature thrusters. But Oumuamua showed no visible comet tail, no glowing coma, no obvious cloud of vaporized material. It accelerated anyway. Suddenly, scientific debate exploded. Was it a comet? An asteroid? A fragment from another planetary system? A nitrogen iceberg? A shattered piece of an alien world? Or something even stranger? At one point, the mystery became so intense that some scientists publicly discussed the possibility, however unlikely, that Oumuamua might even be artificial. An alien probe. That idea dominated headlines around the world. But the real importance of Oumuamua had nothing to do with aliens. Its true significance was far deeper. Because for the first time, humanity directly witnessed an object from another star system moving through our own. The solar system was no longer closed. The barrier between stars had been crossed. And suddenly, the Oort Cloud became even more fascinating. Because if objects can enter the solar system from interstellar space, could objects from our solar system leave as well? The answer is yes. In fact, they almost certainly have. For billions of years, giant planets like Jupiter have gravitationally scattered objects outward. Some comets gain enough energy during close encounters to escape the sun entirely, launched forever into the galaxy. Right now, somewhere in interstellar darkness, there may be frozen objects that originally formed near our sun billions of years ago. Tiny fragments of the early solar system drifting between stars. And if that happened here, then the reverse must also be true. Some objects in the distant Oort Cloud may not belong to the sun originally at all. They may be immigrants from other stars. This changes the emotional feeling of the solar system completely. The outer regions are no longer simply remote. They are porous, connected to the galaxy itself. Imagine the Sun during its earliest years. 4.5 billion years ago, it was not alone in space like it is today. It formed inside a dense stellar nursery, surrounded by countless young stars packed much closer together than modern stars are now. In that crowded environment, stars passed relatively near one another constantly. Their gravitational fields overlapped, planetary systems disturbed each other. Comets and icy debris may have been exchanged between neighboring stars almost routinely. The infant Sun may have captured material from other stellar systems while simultaneously losing some of its own. Which means parts of the Oort Cloud could literally predate Earth itself. Alien ice trapped inside the Sun's gravity for billions of years. That realization transforms the Oort Cloud from a distant comet reservoir into something much stranger. A galactic archive. A frozen collection of objects potentially originating from multiple stars. And Oumuamua was only the beginning. Because in 2019, astronomers discovered another confirmed interstellar visitor. This one behaved differently. Its name was Comet Borisov. Unlike Oumuamua, Borisov looked immediately recognizable. It possessed a visible coma and tail exactly like ordinary comets in the solar system, but its velocity revealed the truth. It too came from another star, and Borisov carried something extraordinary with it. Chemistry. As scientists studied the gases escaping from Borisov, they realized its composition looked both familiar and unfamiliar at the same time. Some chemicals resembled solar system comets. Others existed in noticeably different proportions. It was like examining a fossil from another planetary system. For the first time, humanity could directly compare material formed around another star with material formed around our own. And the implications were enormous. Because Borisov proved interstellar objects are real, natural, and likely common. Oumuamua was not a once-in-eternity anomaly. The galaxy is filled with wandering debris. Countless objects travel between stars constantly. Most are simply too small and dark to notice. But occasionally, one passes through our cosmic neighborhood. And this raises an extraordinary possibility. If interstellar objects regularly move between stars, then perhaps the Oort Cloud itself exists partly because of this exchange. Perhaps the outer solar system is not merely the Sun's distant territory. Perhaps it is also a meeting place between stellar systems. A transition zone where objects drift between suns over billions of years. This idea becomes even stranger once you understand how weak gravity truly is at the edge of the Oort Cloud. Near Earth, the Sun completely dominates motion. Its gravity controls everything, but tens of thousands of astronomical units away, the Sun's hold becomes fragile. A passing star can disturb objects there. The tidal pull of the Milky Way can reshape orbits there. At extreme distances, the Sun is no longer fully in control. And that means the boundary of the solar system is not a wall. It is a gradient, a fading influence dissolving slowly into the galaxy. Imagine drifting near the outer edge of the Oort Cloud. The Sun behind you appears only as a bright star among many others. Ahead lies interstellar darkness. Nearby frozen bodies orbit so slowly that millions of years pass between complete revolutions. And somewhere in that darkness, another star may eventually pass close enough to disturb the entire region. Not tomorrow, not next century, but eventually. Stars are moving constantly through the Milky Way. Over long enough timescales, close stellar encounters become inevitable. And when they happen, the Oort Cloud responds. Scientists believe passing stars have triggered comet showers throughout the solar system's history. Waves of icy bodies may have been knocked inward toward the planets after ancient stellar flybys. Some researchers even investigate whether major extinction events on Earth could partially connect to these disturbances, though the evidence remains debated. Still, the mechanism itself is real. A distant star can influence Earth indirectly from trillions of miles away, simply by disturbing the frozen edge of the solar system. That is how interconnected the galaxy truly is. And now another disturbing thought begins emerging. If our solar system possesses an Oort cloud, then other stars probably do too. Imagine standing far beyond Pluto inside the darkness of interstellar space. Every visible star in the night sky may be surrounded by its own enormous sphere of frozen debris. Vast invisible clouds overlapping silently across the galaxy. The Milky Way may not simply be a collection of stars. It may be a collection of overlapping gravitational oceans filled with ancient ice. And hidden within those oceans may drift objects older than planets themselves. The scale becomes almost impossible to emotionally process. Because once the Oort cloud enters the picture, the solar system stops feeling like a neat planetary arrangement and starts feeling like part of a much larger galactic ecosystem. Comets move between regions. Stars perturb each other's outer clouds. Interstellar debris wanders endlessly through darkness. The boundary between here and out there begins dissolving completely. And this leads to one of the strangest realizations of all. Humanity has never actually seen the Oort cloud. Not directly. Everything we believe about it comes from mathematics, orbital dynamics, simulations, and indirect evidence. We infer its existence because comets behave the way they do. Because gravity predicts the structure should exist. Because the solar system itself makes more sense with it than without it. But no spacecraft has reached it. No telescope has photographed its full shape. In some ways, the largest part of the solar system remains theoretical territory. A hidden kingdom inferred from shadows and trajectories. And yet recent discoveries may have revealed something astonishing hidden inside that darkness. Because in 2024, scientists studying simulations of the Oort cloud noticed a structure nobody expected to find. Not a random sphere. Not featureless chaos. A pattern. A gigantic spiral hidden within the outer solar system itself. And if the discovery is correct, then the galaxy may have literally sculpted the shape of the sun's distant frontier. If you try to imagine the edge of the solar system, your mind naturally builds a picture. A final boundary. A line where the sun's influence ends and interstellar space begins. A place you could theoretically cross, like crossing a coastline into the open ocean. But the deeper scientists studied the outer solar system, the more that idea began to fall apart. Because there is no real edge. No wall. No final border where the sun suddenly stops mattering. Instead, there is something far more unsettling. A fading influence. A gravitational presence that weakens slowly, stretches farther than intuition can follow, and dissolves gradually into the galaxy itself. The Oort Cloud is not a shell with a sharp outer surface. It is a transition, a region where the sun is still dominant, but no longer alone. And the farther outward you go, the more the structure begins to change shape in ways that were completely unexpected. Scientists divide the Oort Cloud into two major regions: the outer cloud and the inner cloud, often called the Hills Cloud. And this distinction changes everything about how we understand the solar system's true size. Because the inner Oort Cloud is not spherical like the outer region. It is not random. It is not evenly spread in all directions. It has structure, a shape, a hidden geometry shaped by billions of years of gravitational forces acting in slow motion. The Hills Cloud is thought to begin somewhere around 2,000 to 5,000 astronomical units from the Sun. That alone is already almost incomprehensible. At that distance, sunlight is so weak that the Sun becomes little more than a brilliant point in the sky. Still the brightest star you would see, but no longer a source of warmth or meaning. Just light, pure distance. But the real mystery begins here. Because unlike the outer Oort Cloud, the Hills Cloud may not be spherical. It may be flattened, thick, disk-like, almost like a distorted echo of the original planetary disk from which the solar system formed. And that immediately raises a disturbing question. Why would one part of the solar system be shaped like a sphere, while another part is shaped like a disk? The answer lies in time, and gravity, and something far larger than the solar system itself. Because the Oort Cloud is not static, it is not frozen in place like a sculpture. It is evolving, slowly, continuously, over billions of years. Every object inside it is being gently pulled, nudged, and reshaped by forces that are almost imperceptible on human timescales. The Sun's gravity holds everything together. But at extreme distances, another influence begins to matter. The Milky Way galaxy itself. This is where things become truly strange. Because the galaxy is not just a backdrop of stars. It is a gravitational system. A massive structure whose combined mass creates tidal forces that stretch across interstellar space. And those tidal forces do not stop at the edge of the planets. They reach deep into the Oort Cloud. At distances of tens of thousands of astronomical units, the galaxy begins to subtly reshape orbits. Not suddenly, not violently, but slowly, like water reshaping sand over geological time. This is why the outer Oort Cloud becomes spherical. Because over billions of years, the galactic tide smooths out orbital directions, spreading objects evenly in all directions until the original disk-like structure disappears completely. But the inner region tells a different story. The Hills Cloud is closer to the Sun, stronger bound, less exposed to the galaxy's full tidal influence. So it retains memory, a partial imprint of the original disk, a transitional shape between the organized plane of the planets and the chaotic sphere of the outer cloud. It is not one structure. It is a gradient, a transformation happening across distances so large that human imagination struggles to keep all the layers in mind at once. But even this is not the most surprising part. Because in recent simulations, scientists discovered something inside the inner Oort cloud that no one expected. A pattern, a structure that looks almost impossible at first glance. A spiral, not a flat spiral like a galaxy seen from above, but a three-dimensional twisting form embedded deep inside the cloud, shaped by the combined influence of the Sun and the Milky Way's gravitational field. At first, researchers thought it might be a simulation artifact, a numerical distortion, a visual illusion created by how data was processed. But when the same pattern appeared again and again under different simulations, the explanation became unavoidable. The inner Oort cloud may contain a spiral structure spanning thousands of astronomical units, a hidden shape carved slowly by the galaxy's tidal forces. This is where the story shifts from space is large to something much deeper. Space is not just large, it is structured. Even at the edge of the solar system, there is organization. Hidden geometry. Patterns shaped by forces that operate on timescales far beyond human history. To understand how strange this is, imagine dropping ink into a perfectly still ocean and returning 1 billion years later. You would not expect randomness. You would expect patterns formed by currents you could never see directly. That is what the inner Oort cloud may be. A record of gravitational currents flowing through the galaxy itself. And this raises a deeper realization. If the galaxy can shape the outermost regions of our solar system, then the solar system is not truly separate from the galaxy at all. It is embedded inside it. Fully, completely, continuously influenced. The boundary between solar system and Milky Way is not sharp. It is blended, gradual, almost indistinguishable at extreme distances. And once you accept that, another idea begins to emerge naturally. The solar system is not an isolated object. It is part of a larger gravitational ecosystem where stars influence each other across vast distances. But there is still something missing from this picture. Something that connects all the layers we have discussed so far. The planets, the Kuiper belt, the scattered disk, Sedna and the detached objects, the Hills cloud, the outer Oort cloud, and now the spiral structure possibly hidden inside the inner region. All of it must have come from somewhere, and the answer takes us back to the earliest moments of the solar system. Before Earth existed, before the planets formed their final shapes, before the Sun even fully settled into the star we see today. The solar system began as a collapsing cloud of gas and dust. A rotating disk called the protoplanetary disk. Inside that disk, tiny particles collided and stuck together, slowly forming larger and larger bodies. Planets were not the only outcome of this process. They were just the largest survivors. Trillions of smaller objects formed at the same time. Icy bodies, rocky fragments, leftover material that never became part of a planet. And as the giant planets formed, especially Jupiter and Saturn, their gravity began reshaping everything around them. They acted like gravitational engines, pulling, scattering, ejecting. Some objects were thrown inward, some outward, some completely out of the solar system entirely, and some were pushed far enough away that they became weakly bound to the Sun, drifting into extremely distant orbits. This is the foundation of the Oort Cloud, a population born from chaos, stabilized by distance, preserved by time, but shaped later by the galaxy itself. This is the key idea most people miss. The Oort Cloud is not just a leftover. It is not just debris. It is a structure built in stages. First by the Sun, then by the planets, then by the galaxy. It is layered history written in ice. And every layer tells a different part of the story. At the inner edge, you still see the influence of the solar system's original disk. In the middle, you see the gravitational reshaping caused by the giant planets. And at the outer edge, you see the galaxy rewriting everything into a spherical structure. This is why the Oort Cloud is so important. Because it shows that the solar system is not a simple object. It is a dynamic system that extends outward into multiple physical regimes at once. Planetary physics near the center, solar gravity in the middle, galactic forces at the edge, all overlapping, all interacting, all shaping the same structure. And this brings us back to the most important realization in the entire story. There is no clean boundary where the solar system ends. Instead, there is a gradual transition into interstellar space. And even that transition is not empty. It is filled with objects, frozen time capsules drifting between stars. Some born here, some possibly born elsewhere, all slowly moving through a shared gravitational environment shaped by the Milky Way itself. And this leads to the final question that completes the picture. If the Oort Cloud is not an edge, and not a wall, and not a boundary, then what exactly is it? The answer is unsettling in its simplicity. It is a region where the Sun's influence becomes indistinguishable from the galaxy's influence. A place where belonging becomes ambiguous, where objects are no longer clearly part of one system or another, where the idea of a single, contained solar system begins to break apart entirely. And once you understand that, the story of the solar system is no longer about planets orbiting a star. It becomes something much larger. A star embedded inside a vast gravitational environment, surrounded by layered structures extending into interstellar space, and slowly dissolving into the Milky Way itself. The solar system does not end at the Oort Cloud. It fades, and what lies beyond it is not emptiness, but continuity. There is a point in every deep space story where numbers stop behaving like information. They stop feeling like measurements, and they start feeling like something else entirely. Something closer to disbelief. The Oort Cloud crosses that point early, but the full impact does not land until you compare it with something real. Something human. Something moving. Something we built. Voyager 1. Launched in 1977, Voyager 1 is the most distant object humanity has ever created. It has been traveling for nearly half a century, continuously moving outward from the Sun at incredible speed by human standards. And yet, on the scale of the solar system, Voyager has barely started. Right now, Voyager is roughly a few hundred astronomical units away from the Sun. That sounds large until you remember what comes next. The inner edge of the Oort Cloud is believed to begin around 2000 to 5000 AU. The outer edge may extend to 100,000 AU or more, which means something uncomfortable but undeniable. Voyager has not even entered the main body of the solar system's largest structure. It is still inside the smallest layer of it. Now imagine what that really means. Everything humanity has achieved in space exploration, every mission, every probe, every signal sent outward, all of it has taken place inside a region that may represent less than 1% of the Sun's true gravitational domain. Less than 1%. That number should feel impossible. But it is not an exaggeration. It is geometry. Because when distances scale this large, human achievements begin to look surprisingly close to home. Even the fastest spacecraft we have ever launched would take thousands of years just to cross the full Oort Cloud. Not months, not years, thousands of years. At Voyager's current speed, the journey to fully leave the Sun's influence stretches into tens of thousands of years. Which means something very important. No human civilization has ever existed for even a fraction of the time needed to cross the solar system's true boundary. And this is where the first real intuition collapse happens. Because most people imagine space exploration as something that is already far away. Mars, the outer planets, maybe even the Kuiper belts. But those regions are still close enough that sunlight is meaningful, gravitational structures are strong, and travel times are at least imaginable. The Oort Cloud is different. It exists in a regime where time itself becomes the limiting factor. Not engineering, not propulsion. Time. Now consider light. The fastest thing in the universe. Light from the Sun takes about 8 minutes to reach Earth. Hours to reach Jupiter. About 4 hours to reach Neptune. But once you move beyond the planetary system, everything changes scale. At the inner Oort Cloud, thousands of AU away, sunlight can take days to weeks to arrive. And at the outer edge, light takes more than a year. That single fact alone reshapes everything. Because it means the Sun is no longer a central light source in any meaningful physical sense. It becomes something else. A distant beacon. A star that you can see clearly but no longer feel. Now imagine standing in that region. Not orbiting Earth's, not inside the planetary system, but inside the outer solar system. Somewhere in the Oort Cloud. Above you is a sky filled with stars. Among them is the Sun. Still bright, still visible, but no longer dominant. It's no longer warm, no longer central in experience. Just another star in a crowded sky. This is the point where the word solar system begins to lose emotional meaning. Because the system no longer feels like a system. It feels like a volume of space where one star happens to be slightly closer than the others. Now step back even further. Let's compress everything into perspective. If the entire planetary system, from the Sun to Neptune, were reduced to the size of a coin, the Oort Cloud would extend far beyond a football stadium, possibly even beyond an entire city. And that is still only a conservative estimate. because some models suggest the outer boundary could stretch to half a light year or more. Half a light year. That number changes everything. Because suddenly, the solar system is no longer a tight planetary family. It becomes a structure that occupies a significant fraction of the distance to the nearest star. Proxima Centauri, 4.24 light-years away. If the Oort Cloud reaches even 1 to 2 light-years, then the Sun's influence extends across a meaningful portion of interstellar space. Not empty space between systems, not a clean separation, but overlap. This is where intuition completely fails. Because humans naturally assume space is divided into neat territories. This star system here, that star system there, empty space in between. But reality is not so clean. The boundaries are fuzzy. Gravitational fields overlap. Objects drift between systems. And the Oort Cloud sits right inside that blurred region. Which means something even more unsettling. The solar system is not isolated. It is entangled with the galaxy. Now return to Voyager again. Voyager is not just far away. It is traveling through a region where definitions begin breaking down. It crossed the heliopause at around 120 AU, the point where the solar wind stops dominating space. That was widely reported as leaving the solar system. But that statement only described one layer, not the full structure. Because the heliopause is not an outer boundary. It is just the edge of the Sun's atmosphere. Like stepping outside a campfire's smoke. You are no longer in the smoke, but you are still very much near the fire. The gravitational influence still extends vastly beyond. This is why scientists separate heliosphere from solar system. One is plasma, one is gravity, and gravity is the real definition of belonging. Now here comes the part where numbers start to feel surreal. If Voyager 1 continues traveling at its current speed, it will take roughly 300 years just to reach the inner Oort Cloud. It will take around 30,000 years to cross the outer boundary. 30,000 years. That number is not about distance anymore. It is about scale of existence. When Voyager finally exits the solar system, human civilization as we know it will have transformed countless times. Languages will evolve. Cities may vanish and reappear. Entire cultures will rise and fall. And Voyager will still be moving through darkness. That single comparison destroys the emotional scale most people carry. Because it reveals something uncomfortable. Human history is microscopic compared to the structure we live inside. Now consider something even more extreme. The Oort Cloud is not static. It is constantly interacting with the galaxy. Passing stars, galactic tides, gravitational nudges from the Milky Way. All of these forces slowly reshape its structure over millions and billions of years. Which means the outer solar system is not just large. It is active, dynamic, evolving, and deeply connected to everything around it. So the final question becomes unavoidable. If the solar system is this large, and this diffuse, and this interconnected, then what exactly are we living inside? The answer is no longer simple. It is not a planetary system, not even just a star system. It is a gravitational environment, a layered structure shaped by the sun, the planets, and the galaxy itself. At the center, planets form. Farther out, planets lose dominance. Even farther, the galaxy begins to reshape everything. And beyond that, there is no clear boundary at all. Just a fading influence stretching outward until it merges with interstellar space. And that leads to the final realization of this entire journey. The solar system does not end. It dissolves. And what we call the edge is only the point where one influence becomes weaker than another. It's not a wall, not a border, not a final step, just a transition in dominance. So when you think about home, you are not thinking about 8 planets. You are not even thinking about Neptune. You are thinking about a structure that may extend halfway to another star. A structure filled with trillions of frozen objects, shaped by the sun, reshaped by the galaxy, and slowly blending into interstellar space. And somewhere inside that vast structure is Earth, a tiny world orbiting a star, inside a system that is far larger, stranger, and more expansive than anything most people ever imagine. And once you see that clearly, you can never go back to the old picture again. There is a moment in every long journey where distance stops being a number and starts becoming a feeling. Not excitement, not curiosity, but a quiet mental resistance, because the human mind was never designed to hold structures this large without breaking its internal models of reality. The solar system has now crossed that point. We have traveled from Earth to Neptune, from Neptune to the Kuiper Belt, from there to Sedna, the scattered disk, the heliopause, and deep into the Oort Cloud, and at every stage the same pattern has repeated itself. What looked like an edge was never an edge. What looked like a boundary was only a transition. But there is still one final problem left. Because even after understanding the Oort Cloud, even after accepting that the solar system is vastly larger than planets, the mind still tries to compress everything into something familiar. A system, a structure, a contained object. But what if that assumption itself is wrong? What if the solar system is not a thing at all? What if it is a region where different physical influences overlap and slowly replace each other? At the center, planetary gravity dominates. Farther out, solar gravity becomes weak but still stable. Farther still, galactic tides begin to interfere. And beyond that, even the identity of belonging to the sun starts to blur. This is not a layered system. It is a gradient of control. And gradients do not have edges. They fade. Now think back to Voyager again. The most distant object humanity has ever created. Still inside this structure. Still moving outward. Still nowhere near the real boundary. And suddenly a disturbing realization appears. If Voyager has not even crossed 0.5% of the solar system's true radius, then everything we consider space exploration is still happening inside the inner skin of a far larger structure. A structure we never visually perceive. A structure we only reconstruct mathematically. because no image exists that can show it fully. Not because we lack technology, but because scale itself becomes invisible at this level. Now imagine something even more extreme. Take the entire orbit of Neptune. Shrink it down to a single point. That point would still not represent the solar system. It would only represent the inner core, the region where planets exist, the region we mistakenly call everything. But beyond that point, the real system begins expanding outward in ways no classroom diagram ever shows. Trillions of icy objects, stretched across distances so large that the gap between them becomes the dominant feature of existence. Not matter, space. And this is where human intuition fails completely again. Because we tend to define structure by density. Cities feel structured because they are dense. Planets feel structured because they are solid. Galaxies feel structured because they are bright and visible. But the outer solar system breaks this rule entirely. It is structured through gravity, not density. Through influence, not appearance. Which means the most important part of the solar system is also the part we cannot see. And that creates a contradiction in human thinking. How can something be the largest part of a system if it is also the most invisible part? The answer is simple. Visibility is not equal to importance. And this is exactly where the solar system hides its true identity. Because everything we see, planets, moons, asteroids, is only the region where matter is concentrated enough to become visible. Everything beyond that is still part of the system, but stretched into near total darkness. Now let's push this even further. Imagine standing at the outer edge of the Oort Cloud. Not as a spacecraft, but as an observer. Above you, stars fill the sky. Below you, stars fill the sky. Every direction is identical. And somewhere among them is the sun. No longer dominant. No longer central. Just one star among billions. At that point, a question naturally forms in the mind. If the sun looks like just another star from here, then what actually makes this region belong to the sun at all? The answer is gravity. But gravity is invisible. It does not shine. It does not emit light. It does not create boundaries you can see. It only defines motion. And motion is the only true signature of structure at this scale. So the solar system is not defined by what you see. It is defined by what moves around the sun. Even at distances where the sun is barely distinguishable from other stars. Even at distances where interstellar space begins to feel equally present. This is why the Oort Cloud becomes so important. Because it is the final expression of solar gravity before it dissolves into the galaxy. And now we reach the most uncomfortable realization yet. There is no moment where the sun stops holding things. There is only a distance where its influence becomes weaker than everything else around it. And that point is not fixed. It shifts depending on passing stars, galactic tides, and time itself, which means the edge of the solar system is not a place. It is a condition, a balance point between forces. And balance points can move. They can stretch. They can fluctuate over millions of years. So even the idea of a stable boundary begins to collapse. Because nothing in this region is truly stable. Everything is slowly interacting with everything else. Stars passing nearby. Objects drifting outward. Icy bodies being pulled inward after billions of years. The solar system is not a frozen diagram. It is a living gravitational environment evolving on timescales far beyond human life. And this brings us to the final shift in understanding. If the solar system has no fixed boundary, then it is not separate from the galaxy in the way we imagine. It is embedded inside it, completely and continuously, not as an isolated system, but as a local distortion inside a much larger gravitational field. And once that realization settles in, the idea of leaving the solar system stops making sense entirely. Because there is no clear line to cross. Only regions of decreasing influence. And that is where Section 7 continues into the final collapse of perspective. Once you accept that the solar system has no hard edge, the next realization becomes unavoidable. If there is no clear boundary here, then there is probably no clear boundary anywhere. Not between planets and space. Not between the sun and interstellar space. And not even between the solar system and the galaxy itself. Because what surrounds us is not a set of separated systems. It is one continuous gravitational environment. The sun sits inside it. So do other stars. So do their outer comet clouds. All overlapping. All interacting. All slowly reshaping each other across time. This is where the Oort Cloud stops being just a solar system structure and starts becoming something much larger in meaning. It becomes a shared region between stars. A transitional space where the influence of one star fades into the influence of another. Now imagine zooming out even further. Far beyond the Oort Cloud. Beyond the region where the sun is dominant. Beyond where even individual stars feel isolated. You begin to enter the true environment of the Milky Way. Not a background of stars, but a gravitational system containing them. The galaxy is not empty space with stars inside it. The galaxy is the structure, and stars are embedded within it like moving points inside a vast rotating field. This changes everything about how distance works. Because now distance is not just separation. It is interaction over time. A star passing nearby does not need to collide with the solar system to affect it. It only needs to pass close enough for its gravity to slightly distort the outer Oort Cloud. And that distortion can travel inward, sometimes taking millions of years to fully show its effect. This means events happening far away in the galaxy can influence the inner solar system on delayed timescales. Not instantly, but eventually, like ripples traveling through a structure too large to perceive as a whole. Now think about that carefully. A star passing millions of years ago could still be shaping the comet activity we see today. That means the sky above Earth is not only a snapshot of the present. It is also a record of past gravitational interactions still unfolding. And this is where intuition begins to break again. because we naturally think of time and space as separate ideas. But in the outer solar system, they are deeply connected. Distance becomes time, and time becomes motion. Now let's return to the Oort Cloud one more time. At its outer edge, the sun is still technically dominant, but only barely. Nearby stars are not just visible in the sky. They are gravitational participants in the same system. This creates something very unusual. A shared boundary region between stars. Not a collision zone. Not a void, but an overlap zone. A region where multiple stellar systems gently influence the same objects across billions of years. And this leads to a radical idea. The Oort Cloud may not belong exclusively to the Sun. It may be partially shaped by the galaxy itself, and possibly even by other stars that have passed through this region in the past. In other words, the outer solar system may be a shared historical space, a place where stellar histories overlap. Now expand that idea. If one star system can have overlapping outer regions, then this might be a universal feature of the galaxy. Every star could be surrounded by its own Oort-like structure, and these structures could overlap like invisible spheres filling the Milky Way. Not touching like solid objects, but intersecting through gravitational influence. If that is true, then the galaxy is not a collection of isolated solar systems. It is a continuous network of overlapping gravitational spheres, each star shaping a region far larger than its visible system. And this leads to another unsettling realization. We tend to imagine interstellar space as empty, but in reality, it may be filled with extremely low-density structures belonging to multiple stars at once. A kind of shared gravitational ocean. Slow, diffuse, almost impossible to detect directly, but mathematically unavoidable. Now return again to Voyager. Still traveling, still inside this environment. Even after leaving the heliosphere, it has not left this overlapping region. Because the heliosphere is only the Sun's plasma boundary, not its gravitational boundary, not its galactic boundary, not even close. Voyager is moving through a space where the Sun is still subtly present, still influencing motion, still defining a weak but real directionality in space. And that is why the phrase, leaving the solar system, becomes misleading at every level. Because it assumes a clean exit. But there is no exit. Only transition. Only fading influence. Only gradual blending into something larger. Now zoom out again. Far beyond Voyager. Far beyond the Oort Cloud. Far beyond even the idea of a single star system. You reach the Milky Way itself. A rotating structure containing hundreds of billions of stars. Each one surrounded by its own gravitational environment. Each one slowly interacting with the galaxy as a whole. And now the most important shift happens. The solar system is no longer the main unit of structure. It is just one local variation inside a galaxy-wide system. A temporary gravitational zone inside a much larger field. And suddenly the question changes completely. it is no longer. How big is the solar system? It becomes, how do you even define a system inside something this continuous? Because the boundaries we imagined were never physical. They were conceptual, human-made categories to simplify something that does not naturally separate cleanly. And once those categories start dissolving, something strange happens. The solar system stops feeling like a place and starts feeling like a process, a region where gravity organizes matter temporarily, before everything slowly re-enters larger galactic motion. This is the real context of the Oort Cloud. Not as an edge, not as a shell, but as a transition layer where solar influence gradually yields to galactic influence. And once you understand that, the idea of outside the solar system stops being a meaningful location. Because there is no outside, only continuation. Once you reach this point in the structure of the solar system, something subtle but powerful happens. The problem is no longer about how far things are. It is about what far even means. Because distance stops behaving like a clean measurement and starts behaving like a distortion of perspective. The further you go, the less useful your intuition becomes, and eventually, even the language used to describe space begins to break under its own weight. At the center of everything, the idea feels simple. A sun, planets, and then space beyond them. But every layer you add beyond that simple picture removes another piece of certainty. The Kuiper Belt already challenged the idea of a neat planetary boundary. The scattered disk stretched it further. The heliosphere showed that even the sun's influence has multiple layers. And then the Oort Cloud revealed something even more uncomfortable. That the solar system does not end where brightness ends. It ends where influence becomes too weak to notice directly. And that difference changes everything. Because now you are no longer dealing with objects arranged in a system. You are dealing with a field of influence that gradually dissolves into the galaxy. There is no final wall where the sun stops existing in any meaningful way. There is only a gradual reduction in control, spread across distances so large that no human experience can naturally map them. And this is where even structure becomes a misleading word. Because structure implies clarity, edges, forms, but what exists at this scale is closer to interference between forces that never fully separate. The sun pulls outward. The galaxy pulls sideways. Passing stars tug gently at extreme distances. And all of this happens continuously, over millions and billions of years, without ever producing a single clean dividing line. So when we say outer solar system, we are not describing a place. We are describing a region where multiple gravitational identities overlap. Now bring all of this back to Voyager one last time. It is still moving outward, still crossing thresholds defined by human models. But none of those thresholds represent an actual ending. The heliopause was not an exit. It was just the point where the solar wind stops dominating local space. The Kuiper Belt was not an edge. It was just the last dense region of icy debris close enough to form recognizable patterns. And the Oort Cloud is not a boundary either. It is the slowest, widest expression of solar influence, still holding on before dissolving into the galaxy. So even Voyager, the farthest human object ever created, is not leaving, anything in the way people imagine. It is moving through layers of decreasing influence, not crossing a border, but passing through gradients. And this is where the mental model finally collapses, because the idea of a system requires separation, inside and outside, here and there, start and end. But the solar system does not obey that structure at large scales. Instead, it behaves like a continuum, a smooth transition from strong solar dominance near Earth to weak solar influence at thousands of AU, to mixed solar, galactic interaction in the Oort Cloud, to full galactic dominance beyond it. No jump, no edge, no final step, just transformation. And once you accept that, even the word system starts to feel too rigid. Because systems are supposed to be contained. But this is not containment. This is blending, which leads to the final realization. The solar system is not an object sitting inside the galaxy. It is a region inside the galaxy where the sun's influence is still in the process of fading. And that fading has no fixed endpoint. It just continues until it becomes indistinguishable from everything around it. So when you imagine the Oort Cloud now, it should not appear as a shell at the edge of something. It should appear as a soft outer atmosphere of the sun's influence, stretching outward into interstellar space, mixing with the gravitational fields of other stars, interacting with the Milky Way itself, and slowly dissolving into the larger structure of the galaxy. This is why interstellar space is not truly empty. It only appears empty from a human scale. On cosmic scales, it is filled with overlapping zones of influence from countless stars, all extending far beyond what we can see. And in that sense, the Oort Cloud is not the end of anything. It is a meeting region, a boundary that refuses to stay fixed, a place where belonging becomes ambiguous and shared. And that leads to the final shift in understanding. The solar system was never a closed environment separated from the universe. It was always part of it, always interacting, always leaking influence outward and receiving influence inward. A temporary structure inside a much larger, continuous gravitational system. And once you see it this way, the original question loses its meaning entirely. There is no point where you can say, this is no longer the solar system. Because every layer you cross is still connected by gravity, history, and motion. What changes is not membership. What changes is dominance. The sun becomes less dominant, then barely dominant, then just one influence among many, until eventually it is no longer distinguishable as a defining force in that region. And beyond that, there is no sudden transition, only continuity. So the final truth is simple, but deeply counterintuitive. The solar system does not end at the Oort Cloud. It does not end at Voyager. It does not even end at the heliopause. It gradually fades into the galaxy itself. And what we call its edge is only the point where human intuition can no longer track the scale of that fading. So in the end, the most accurate way to describe the solar system is not as a bounded structure, but as a gravitational story still unfolding. A star surrounded by layers of diminishing influence, expanding outward into interstellar space, and slowly becoming indistinguishable from the Milky Way that contains it. And from that perspective, the most surprising realization is this: we were never standing at the edge of a system. We were always inside its middle, inside something that has no edge at all. The moment you truly understand the scale of the Oort Cloud, another question appears almost automatically. Could humanity ever actually reach it? Not theoretically, not through simulations or mathematical models. Physically, could human beings born on Earth ever travel across the true scale of the solar system? Because once the numbers become emotionally real, something uncomfortable begins happening inside the mind. The greatest journeys in human history suddenly start looking microscopic. Crossing oceans once felt impossible. Ancient civilizations believed the world simply ended beyond distant horizons. Then ships crossed seas, railroads crossed continents, aircraft crossed skies. Eventually, rockets carried humans beyond Earth itself. And for a brief moment in the 20th century, it felt like humanity had entered the beginning of an endless expansion outward. The moon seemed like step one. Mars felt inevitable. The outer planets looked distant but reachable. Interstellar travel slowly moved from fantasy into serious scientific discussion. But the Oort Cloud changes the emotional scale of exploration completely. Because the problem is no longer engineering alone. It is time. Voyager 1, the most distant spacecraft humanity has ever built, launched in 1977, long before smartphones existed, before the internet connected the planet, before most people alive today were born. And even after nearly half a century of continuous motion, Voyager has still not reached the true beginning of the Oort Cloud. That fact does not sound real at first. The spacecraft is moving more than 17 kilometers every second, fast enough to cross entire countries in minutes. Fast enough to escape every planet in the solar system forever. And yet on the scale of the Sun's true gravitational territory, Voyager is barely beginning the journey. This is where human intuition collapses again. Because the human brain naturally measures achievement emotionally, not mathematically. If something has been traveling for 50 years, we instinctively assume it must be unimaginably far away. And by normal standards, it is. But the Oort Cloud does not obey normal standards. At Voyager's current speed, reaching the outer regions of the Oort Cloud could take tens of thousands of years. Not decades, not centuries, longer than recorded civilization itself. When Voyager finally exits the Sun's distant gravitational influence, every nation alive today will be gone. Every building on Earth will have vanished. Languages will evolve beyond recognition. Entire chapters of human history, not yet written, will already be ancient. And still, the spacecraft will continue drifting through darkness. That realization changes the emotional meaning of space exploration. Because for the first time in human history, our species has discovered a frontier so large that civilization itself may not survive long enough to cross it conventionally. The distances are no longer merely difficult. They are generational, civilizational, possibly evolutionary. And suddenly, the future of exploration begins looking very strange. Because reaching the Oort Cloud may require humanity to stop thinking like individual travelers and start thinking across timescales far beyond ordinary human life. This is where concepts like generation ships begin appearing seriously in scientific discussions. A generation ship is exactly what the name implies. A spacecraft so slow and traveling so far that the original crew would never survive to reach the destination. Instead, entire generations would live and die aboard the vessel while it continued drifting outward through interstellar darkness. Children would be born on the ship, grow old on the ship, die on the ship, all while moving toward destinations nobody on board originally chose. Imagine what that would feel like psychologically. An entire civilization existing inside a moving structure, surrounded by infinite blackness. No nearby planets, no rescue, no possibility of returning home. Only distance. And somewhere impossibly far behind the ship, the sun reduced to another bright star among thousands. At that point, exploration stops resembling adventure. It starts resembling permanent separation from Earth itself. And the farther outward you imagine traveling, the stranger the emotional consequences become. Because space is not only physically hostile, it is psychologically hostile. Human beings evolved beneath open skies, surrounded by oceans, weather, forests, and constant sensory change. Every instinct in the human nervous system expects movement, sunlight, biological life, and environmental variation. Deep space offers none of those things, especially not near the Oort Cloud. Out there, darkness becomes permanent. The nearest star systems remain unimaginably distant. There are no nearby worlds filled with atmosphere or light. Even sunlight itself begins losing emotional meaning. This is difficult to explain properly unless you imagine it directly. Picture yourself standing near Earth at night. The moon illuminates the landscape. Cities glow beneath clouds. The sky feels alive with movement and atmosphere. Now imagine standing somewhere thousands of astronomical units from the sun. There are no cities, no planets nearby, no visible atmosphere, only stars, and among them one slightly brighter point. The sun is not warm, not central, just another star. This is the moment where the solar system emotionally stops feeling like home. And that creates another problem humanity rarely discusses. Communication. Light travels faster than anything else in the universe. Every signal humanity sends into space moves at light speed. And even light becomes slow across distances like these. Messages sent from Earth to Voyager already take many hours to arrive. Near the outer Oort Cloud, communication delays would stretch into weeks or even months depending on position. Imagine trying to maintain a civilization under those conditions. A child asks a question. The answer arrives months later. An emergency occurs. Help cannot come, not because nobody cares, but because physics itself prevents immediacy. At those distances, every human community becomes isolated by default. And that isolation changes civilization fundamentally. Because civilization depends on connection, trade, shared information, rapid coordination. The Oort Cloud pushes all of those systems toward breaking points, which is why many scientists believe the first true explorers of the distant outer solar system may not be humans at all. They may be machines. Artificial intelligence changes the equation completely because machines do not experience time psychologically the way humans do. A probe does not become lonely. It does not grow impatient. It does not fear dying of old age before reaching its destination. An artificial explorer could drift through darkness for thousands of years with no emotional suffering at all. And in some ways, humanity is already moving toward this model. Voyager itself is a machine carrying fragments of human civilization outward long after its creators began disappearing. The spacecraft contains sounds from Earth, images, music, greetings recorded in dozens of languages. A tiny archive of humanity drifting toward the stars. And perhaps that is the first honest version of interstellar exploration. Not humans physically crossing the galaxy like science fiction heroes, but civilizations sending pieces of themselves slowly outward across deep time. Messages instead of migrations. Memory instead of presence. Because once distances become this large, the universe begins forcing humility onto every intelligent species living inside it. Even the speed of light starts feeling limited. This is why some scientists study propulsion systems that sound almost impossible today. Fusion drives, antimatter engines, laser sails pushed by gigantic beams of light, nuclear pulse propulsion, theoretical concepts capable of reaching significant fractions of light speed. Because unless humanity learns to travel dramatically faster, the outer solar system may remain forever beyond meaningful human reach. But even these advanced concepts create disturbing consequences. Suppose humanity eventually builds a spacecraft capable of traveling 10% the speed of light. An almost unimaginable technological breakthrough. At that speed, reaching the outer Oort Cloud suddenly becomes possible within a human lifetime. But another strange effect appears. Earth itself changes while you travel. Civilizations evolve. Politics transform. Generations disappear. You may leave one version of humanity behind and arrive to find an entirely different civilization waiting when you return. Relativistic exploration disconnects travelers from time itself. And suddenly the emotional meaning of distance changes again. Distance becomes separation not only through space, but through history. This is one reason deep space exploration feels psychologically different from every previous human frontier. Ancient sailors crossing oceans still remained connected to the same world. Different continents existed beneath the same sky and within the same flow of human time. But deep space creates temporal isolation. The farther outward you travel, the less connected you remain to the civilization that launched you. And nowhere does that feeling become stronger than near the Oort Cloud. Because the Oort Cloud sits at the threshold between stellar systems themselves. A transition zone where the sun begins fading into the galaxy. Imagine a future spacecraft moving through that region. Behind it lies the planetary system humanity once called home. Ahead lies interstellar darkness. The sun no longer dominates the sky. Nearby stars appear almost equally important. And for the first time, the crew realizes something emotionally overwhelming. They are no longer psychologically inside the solar system. Not in the way humans have understood it for thousands of years. This is why the Oort Cloud matters so much philosophically. It forces humanity to confront the true scale of existence beyond Earth. The planets once felt enormous. Then the solar system became enormous. Then the Oort Cloud transformed even the solar system into something bordering on interstellar scale. Every step outward destroys another layer of human intuition. And eventually, a terrifying possibility emerges. Maybe intelligent civilizations across the galaxy all face the same barrier. Not extinction, not war, distance itself. The universe may simply be too large for civilizations to expand easily between stars. Physics may naturally isolate intelligent species inside vast gravitational islands separated by impossible time. If that is true, then every civilization in the galaxy may spend most of its existence staring outward into darkness, aware of other stars, but trapped by scale. And suddenly the night sky feels lonelier than before. Because the universe is not empty. It is simply enormous beyond emotional comprehension. Yet strangely, this realization also makes humanity's existence feel more meaningful. Because against impossible scale, conscious life still emerged. Tiny beings on a small rocky planet learned enough physics to understand structures they may never physically reach. A species evolved beside rivers and forests somehow discovered the true size of the sun's invisible territory. And even if humanity never crosses the Oort Cloud completely, understanding that it exists already changes us. Because knowledge expands civilization emotionally before exploration expands it physically. Long before humans crossed oceans, maps changed the shape of human imagination. The Oort Cloud may be doing the same thing now, expanding the mental boundary of what humanity considers home. Not 8 planets, not even the heliosphere, but an immense fading structure extending deep into interstellar darkness. A structure so large that sunlight itself takes over a year to cross it. And somewhere inside that vast gravitational territory drifts one tiny species asking questions about the universe. Still looking outward. Still trying to understand how far the darkness really goes. There is something psychologically dangerous about truly understanding scale. Not because large numbers are frightening by themselves, but because they quietly destroy the illusion that human experience exists near the center of reality. The Oort Cloud does that more effectively than almost anything else in astronomy. Because once you finally grasp its size, something subtle begins happening inside your mind. Earth starts shrinking. Not physically, of course, but emotionally. Civilization begins feeling smaller. History begins feeling shorter. Human conflicts start looking strangely temporary against distances so enormous that even light itself struggles to cross them quickly. And the strange part is, this realization does not arrive all at once. It happens gradually. First, the planets stop feeling large. Then the planetary system stops feeling large. Then eventually, even the sun begins feeling less like the center of reality and more like a local feature inside something vastly bigger. That is the true psychological effect of the Oort Cloud. It dismantles human scale piece by piece. Because for most of human history, people unconsciously believed reality was built around human experience. Ancient civilizations placed Earth at the center of the cosmos. Later, science removed Earth from the center, but still left the sun psychologically important. Even modern people often imagine the solar system as a meaningful unit in the universe. But the Oort Cloud quietly breaks that illusion too. Because once the solar system stretches halfway toward another star, the entire idea of a compact, meaningful neighborhood begins collapsing. And the deeper you think about it, the stranger it becomes. Right now, Earth feels stable, permanent. Civilization feels important because human lives are short. Nations rise and fall across centuries, and those centuries feel enormous to us. Ancient ruins already seem unimaginably old. Entire empires feel buried beneath impossible stretches of time. But the outer solar system does not operate on human timescales. Objects there move so slowly that human civilization barely registers against their motion. Some Oort Cloud bodies may take millions of years to complete a single orbit around the Sun. Millions. Human civilization, by comparison, has existed for only a tiny fraction of that. Modern technological civilization, even smaller. And suddenly, the emotional hierarchy changes. Human history no longer feels ancient. It feels recent. Extremely recent. Like the final seconds of a much larger timeline still unfolding around us. This is one of the most unsettling transitions the human mind can experience. Because humans evolved to understand survival locally. Your brain measures life in days, years, generations. It understands storms, seasons, distances you can physically travel. Even cities and nations are already pushing the limits of emotional comprehension. But astronomy breaks those instincts completely. Especially here. Because the Oort Cloud introduces scales where not only distance, but meaning itself begins stretching beyond intuition. Imagine standing on a frozen object near the outer edge of the cloud. There is no sound, no atmosphere, no nearby worlds, no glowing planets dominating the sky. Only stars, and among them is the Sun. From Earth, the Sun controls everything. It defines day and night, weather, climate, biology, energy, motion. Human civilization exists because of it. But from the outer Oort Cloud, the Sun loses its emotional authority. It becomes one star among many. Still technically home, but visually indistinguishable from countless other points of light. That realization is psychologically difficult because humans instinctively associate importance with visibility. Things that dominate our sky feel central. Things that appear distant feel irrelevant. But the Oort Cloud reverses that intuition completely. The Sun remains gravitationally dominant even when it no longer looks dominant. And that means human perception is deeply unreliable at cosmic scales. What feels central often is not. What feels large often is microscopic. What feels permanent often exists only briefly. And nowhere is that more obvious than Earth itself. Because from the perspective of the outer solar system, Earth is essentially invisible. Not metaphorically, literally. Every war in human history, every city ever built, every language, every religion, every empire, every human being who ever lived. All of it exists on a tiny world that disappears completely at sufficient distance. Even powerful telescopes would struggle to identify it clearly from the outer reaches of the Oort Cloud. That is difficult for the human ego to process. Because humans naturally imagine themselves as visible participants in reality. But astronomically speaking, we are almost undetectable. And the unsettling part is this. The universe does not become emotionally smaller once you understand that. It becomes larger, far larger, because once Earth stops feeling central, your perspective begins expanding outward automatically. You stop thinking in terms of nations, then planets, then even stars. Instead, you begin thinking in structures, systems, fields, processes unfolding across scales too large for instinct to emotionally contain. This is why astronomy affects people psychologically in ways they often struggle to describe. It creates a confrontation between human intuition and cosmic reality. And cosmic reality wins every time. The Oort Cloud especially forces this confrontation because it destroys the illusion of neat boundaries. Humans like boundaries. Continents, countries, shorelines, walls, edges. We psychologically depend on contained spaces because contained spaces feel understandable. But the outer solar system refuses containment. It fades gradually into interstellar space. And interstellar space fades into the galaxy. And the galaxy itself exists inside even larger structures. Every boundary dissolves under sufficient scale. And eventually, you realize something uncomfortable. Human beings do not naturally perceive reality accurately. We perceive locally, emotionally, conveniently. The universe itself is under no obligation to feel intuitive to us. Now imagine explaining the true scale of the solar system to someone from ancient history. Not with modern diagrams. Not simplified. The real scale. Tell them the planets occupy only a tiny inner fraction of the sun's actual domain. Tell them trillions of frozen bodies drift in darkness halfway to another star. Tell them comets may require millions of years to complete their journeys. Tell them the sun itself eventually becomes visually indistinguishable from the surrounding stars. The entire concept would sound impossible. Not because ancient humans lacked intelligence, but because the human brain itself struggles to emotionally process scales this large. Even modern people struggle. That is why most illustrations of the solar system quietly distort reality. The real spacing between planets is usually compressed. The outer regions are cut away entirely. The Oort Cloud is often ignored or shown as a simplified shell, because accurate scale becomes visually unusable. Reality itself stops fitting comfortably inside human imagination. And this creates a strange paradox. The more accurately we understand the universe, the less emotionally intuitive it becomes. The Oort Cloud represents that paradox perfectly, because scientifically it makes sense. The orbital mechanics work. The comet trajectories fit. The gravitational models are consistent. Mathematically, the structure is believable. But psychologically, it feels unreal. Not fictional, just emotionally incompatible with ordinary human scale. And maybe that is why people are drawn to astronomy in the first place. Not because it makes humanity feel larger, but because it reveals how astonishing reality already is without needing exaggeration. The real universe is already stranger than most fiction. A star surrounded by an invisible sphere of ancient ice extending deep into interstellar darkness. A structure so enormous that human civilization has not existed long enough for a spacecraft to cross it. A boundary that is not truly a boundary. A solar system that slowly dissolves into the Milky Way itself. None of that sounds emotionally normal. Because it is not. And yet it is real. Now another realization begins emerging. The Oort Cloud is not only about distance. It is also about isolation. Because the farther outward you travel, the quieter the universe becomes. Near Earth, space feels busy. Satellites orbit constantly. Radio signals flood the atmosphere. Human activity surrounds the planet. Even deep space probes remain connected to mission control through streams of data traveling invisibly through space. But in the outer Oort Cloud, all of that disappears. No nearby planets. No sunlight strong enough to create warmth. No visible signs of civilization. Just cold, darkness, an extraordinary separation between objects. Even neighboring Oort Cloud bodies may be billions of miles apart. That means an observer there might see absolutely nothing nearby at all. Not because the region is empty, but because it is too large for density to feel meaningful. And this changes the emotional feeling of the solar system completely. The planetary region feels structured. The Oort Cloud feels existential. Because once the distances become large enough, isolation itself becomes part of the environment. And suddenly, Earth starts feeling unusual. Rare, not necessarily unique in the universe, but precious in a very specific way. Because Earth exists in a narrow region where complexity can survive. Warmth, liquid water, atmosphere, biology, memory, culture, civilization. All of it exists inside a tiny illuminated zone, surrounded by incomprehensible darkness. And that darkness is not empty. That is the important part. The darkness has structure, history, motion, gravity, ancient objects drifting through timelines larger than civilizations. The Oort Cloud is not dead space. It is deep time made physical. Frozen remnants from the birth of the solar system, still orbiting billions of years later. Some of those objects formed before Earth fully existed. Before oceans. Before life. Before continents settled into their modern forms. And they are still there. Still moving. Still circling the sun slowly through interstellar darkness. That realization changes how you see time itself. Human lives feel linear because they are short. But cosmic structures evolve across durations so vast that beginning and ending lose their ordinary meaning. The Oort Cloud has existed longer than complex life on Earth. And it may continue existing long after humanity disappears. Not because humans are insignificant, but because cosmic structures operate on entirely different scales of persistence. And this leads to perhaps the most unsettling realization of all. The universe does not appear designed around human perception. We evolved inside one tiny environment and assumed its scale felt natural. But nothing about cosmic reality is obligated to fit comfortably inside human intuition. The Oort Cloud reveals that brutally. It shows that home is vastly larger than instinct suggests. That boundaries dissolve. That stars influence each other across unimaginable distances. that even the solar system itself is partially a galactic structure. And once you internalize that fully, something changes permanently. You stop imagining the universe as a collection of nearby objects separated by emptiness. Instead, you begin seeing it as one enormous connected environment, unfolding across scales beyond ordinary comprehension. The Oort Cloud is where that transformation begins. Not because it is the largest thing in the universe, but because it is large enough to break human intuition while still technically being home. And that is what makes it psychologically dangerous. It forces the human mind to confront a reality that no longer revolves around human scale. A reality where Earth is tiny, where the sun is local, where even the solar system itself slowly dissolves into something larger. And once you truly see that, the night sky never looks the same again. For almost the entire history of our species, human beings looked at the night sky and believed they were seeing distance. Stars separated by darkness. Tiny points scattered across empty space. But the deeper astronomy advanced, the stranger reality became. Because the universe is not truly divided into isolated islands. It is connected, not always physically, not by solid structures or visible bridges, but through gravity, motion, time, and enormous overlapping regions of influence, stretching far beyond what human intuition naturally expects. The Oort Cloud reveals that better than almost anything else we have ever discovered. Because once you understand it fully, the solar system stops feeling like a neatly packaged system of planets orbiting a star. Instead, it begins feeling like part of a much larger cosmic continuum. A layered structure slowly blending into the galaxy itself. And strangely enough, this realization changes not only how you see space, but how you see Earth. Because Earth was never sitting at the edge of a completed system. It was always deep inside something far larger than human beings initially realized. A tiny illuminated world orbiting inside an enormous gravitational environment extending into interstellar darkness. And the deeper scientists look, the more obvious it becomes that the boundaries humans imagined were never truly real. They were psychological shortcuts, useful simplifications, but not reality itself. Think about how human beings naturally draw maps. Countries have borders. Cities have edges. Oceans have coastlines. We instinctively organize reality into separated regions because the human brain depends on manageable categories to function. But space does not naturally obey those categories. The heliosphere fades outward gradually. The Oort Cloud becomes thinner with distance. The sun's gravity weakens slowly instead of ending sharply. And eventually, the distinction between solar system and galaxy becomes difficult to define with precision. Not because scientists are confused, but because nature itself does not create perfectly clean separations. Reality is layered, continuous, overlapping. The Oort Cloud exists inside that overlap. And once you accept that, another realization quietly emerges. If the outer solar system blends into the galaxy, then perhaps galaxies themselves also blend into larger structures. And they do. Galaxies orbit inside clusters. Clusters connect into filaments. Filaments form enormous cosmic webs stretching across the observable universe. Every scale reveals larger structure, larger context, larger systems surrounding the ones beneath them. And suddenly, the Oort Cloud stops feeling like an isolated astronomical curiosity. It becomes part of a repeating pattern throughout the cosmos. Small systems embedded inside larger systems. Worlds inside stellar structures. Stars inside galaxies. Galaxies inside cosmic networks. Every layer connected to something beyond itself. That pattern changes the emotional meaning of home. Because home is no longer simply Earth, nor the solar system, nor even the Milky Way alone. Home becomes nested reality itself. A sequence of structures extending outward across scales the human brain was never designed to intuitively comprehend. And maybe that is why astronomy feels emotionally overwhelming to so many people. Not because the universe is hostile, but because it is vastly larger and more interconnected than human instincts prepared us for. The Oort Cloud represents one of the first places where that truth becomes impossible to ignore. Because it stretches the solar system beyond ordinary intuition while still technically remaining part of our local cosmic environment. It forces a confrontation between emotional scale and physical reality. And once that confrontation happens, the universe stops behaving like background scenery. It starts feeling active, dynamic, continuous. Now imagine the sun from the perspective of another distant star. Not from Earth's, not from inside the planetary system, but from several light years away. Our sun would look unremarkable. One star among billions. No visible planets. No obvious signs of civilization. And surrounding it, extending invisibly into darkness, would likely be an enormous cloud of frozen debris impossible to detect directly from that distance. The same is probably true for countless other stars we see tonight. Many may possess their own Oort clouds, their own distant comet reservoirs, their own overlapping gravitational frontiers slowly interacting with the galaxy around them. That means the Milky Way may not merely contain stars. It may contain billions of overlapping stellar territories extending deep into shared interstellar space. Invisible structures nested within larger invisible structures. A galaxy filled not only with stars, but with enormous fading spheres of influence surrounding each one. And somewhere inside one of those spheres, human civilization emerged. That realization creates a strange emotional effect. It makes humanity feel small, but at the same time strangely connected. Because Earth is not isolated from the universe, it is participating in it. The atoms inside your body were forged inside ancient stars. The planet itself formed from cosmic debris orbiting a young sun. The outer solar system interacts gravitationally with the Milky Way. Even comets striking Earth may have begun their journeys because of distant stellar encounters millions of years ago. The universe is not out there. We are inside it completely, embedded within processes vastly older and larger than ourselves. And the Oort Cloud reveals that in a uniquely powerful way because it physically connects local space to interstellar space. It acts almost like a bridge between scales. Near the center of the solar system, planetary physics dominates. Farther out, solar gravity dominates. Beyond that, galactic tides begin reshaping orbits. The farther outward you travel, the less isolated the solar system becomes. Until eventually, the distinction between local and galactic processes starts dissolving entirely. This is one of the deepest transitions in all of astronomy. The realization that systems humans imagined as separate are actually continuous. And once you begin noticing that pattern, you see it everywhere. Earth is not separate from biology. Biology is not separate from chemistry. Chemistry is not separate from stellar evolution. Stars are not separate from galaxies. Galaxies are not separate from cosmic structure. Every level emerges from larger connected processes beneath it. Nothing exists alone. Not even the solar system. Now think again about Voyager 1. Still traveling outward. Still carrying human-made objects into interstellar darkness. A tiny machine built by a young technological civilization, orbiting a small star inside one galaxy among billions. And yet Voyager itself contains something extraordinary. Not advanced technology, not powerful engines. Perspective, because Voyager forced humanity to emotionally confront the scale of the environment surrounding us. Especially through one famous image. The pale blue dot. When Voyager turned its camera back toward Earth from billions of miles away, our planet appeared almost invisible. A tiny suspended point inside darkness. Carl Sagan later reflected on that image with words that became legendary because they captured something humans rarely experience clearly. Perspective stripped of ego. Every empire, every war, every human life, contained inside a nearly invisible fraction of cosmic reality. The Oort Cloud expands that realization even further. Because the pale blue dot image still came from relatively nearby on cosmic scales. Voyager had not even remotely approached the outer solar system yet. Which means Earth can become vastly smaller still. And eventually even the Sun itself shrinks into insignificance against larger galactic structure. This is not depressing. At least not necessarily. In some ways, it is liberating. Because once humanity stops imagining itself as the center of existence, reality becomes far more astonishing. The universe no longer feels like a stage built for human history. It becomes something far stranger and far more beautiful. A vast evolving structure capable of producing stars, planets, life, consciousness, memory, and civilizations naturally through physical processes unfolding across billions of years. The Oort Cloud is part of that story. Not as decoration, not as empty background, but as evidence that cosmic structure extends farther and behaves more subtly than ordinary human intuition expects. And maybe the most fascinating part is this. Human beings discovered all of this while trapped on a tiny planet near the center of the system. No spacecraft has crossed the Oort Cloud. No astronaut has visited it. No direct image fully reveals its shape. Most of what humanity knows about the outer solar system comes from mathematics, observation, and inference. From noticing patterns, tracking comets, understanding gravity, building mental models larger than direct human experience. That alone is extraordinary. A species that evolved to survive on African plains eventually learned to map structures extending halfway toward other stars. Not because the universe was designed for us to understand easily, but because human curiosity pushed outward farther than instinct ever intended. And that curiosity may be the most important thing in this entire story. Because the Oort Cloud is not only an astronomical structure, it is also a symbol of intellectual expansion. Every generation of humans believed they roughly understood the scale of reality, until new discoveries shattered the old boundaries again. First, Earth seemed central. Then the solar system expanded. Then the galaxy. Then the observable universe. Again and again, human understanding moved outward. And each expansion changed humanity psychologically. The Oort Cloud represents one of those expansions. A reminder that even our own local neighborhood is vastly larger and stranger than previous generations imagined. And that realization carries an important implication. There are probably more boundaries waiting to dissolve. More assumptions waiting to collapse. More hidden layers of structure still beyond human understanding. Because history suggests something very consistent about science. Every time humans think they have reached the edge of understanding, reality continues farther outward. The Oort Cloud itself emerged from that exact process. Scientists once believed the planets defined the solar system. Then comets revealed something larger. Then galactic tides revealed something larger still. Then interstellar objects like Oumuamua revealed that even stellar systems exchange material with one another. Every answer opened larger questions. And perhaps that process never truly ends. Now imagine future civilizations. Not decades from now. Thousands of years. Millions. A civilization capable of traveling through the outer Oort Cloud directly. What would they discover there? Captured objects from other stars. Ancient untouched remnants from the birth of the solar system. Unknown structures shaped by galactic tides. Perhaps entirely new categories of objects humanity has not yet imagined. Because the truth is simple. The largest region of our own solar system remains almost completely unexplored. Humanity understands Mars better than the distant frontier surrounding our star. And that frontier may contain clues not only about the solar system's formation, but about the galaxy itself. Now the emotional meaning of the Oort Cloud shifts one final time. At first it felt like distance, then scale, then psychology, then galactic structure, but ultimately it becomes something else. It's humility, not humiliation, not hopelessness. Humility in the deepest scientific sense. The recognition that reality is larger than instinct, larger than perception, larger than ordinary human categories, and yet still understandable, at least partially, through patience, observation, and thought. The Oort Cloud teaches that lesson perfectly, because it exists almost entirely beyond direct human experience. Invisible, dark, nearly impossible to observe directly. And yet, through reason and evidence, humanity uncovered its existence anyway. That is remarkable. A tiny species on a small planet inferred the presence of a colossal invisible structure extending into interstellar space simply by studying the behavior of comets. That achievement says something important about intelligence itself. Not that humans are cosmically important, but that consciousness allows the universe to become aware of its own structure. Through us, matter organized itself into beings capable of asking questions about reality, capable of measuring stars, capable of imagining the edge of the solar system, even while standing deep inside it. And perhaps that is the most beautiful part of this entire story. The universe does not need to revolve around humanity for human curiosity to matter. Meaning does not require centrality. The Oort Cloud proves that. Because even after discovering how enormous and diffuse the solar system truly is, humans still looked outward, still asked questions, still tried to understand. And maybe that is what defines civilization more than anything else. Not power, not technology, but the refusal to stop exploring beyond the limits of instinct. The refusal to accept familiar diagrams once reality proves they are incomplete. The refusal to believe the visible edge is the true edge. The Oort Cloud destroyed the old image of the solar system. But in doing so, it replaced it with something far more extraordinary. Not a compact arrangement of planets orbiting neatly in darkness, but a vast layered structure extending deep into the galaxy. A gravitational frontier filled with ancient ice, invisible motion, and fading stellar influence. A system without a sharp boundary. A home that dissolves gradually into interstellar space. And somewhere near the warm center of that enormous structure, on a tiny planet orbiting an ordinary star, a civilization briefly looked outward and realized how astonishing reality truly was. And maybe that is the strangest part of all. After everything we have explored, the planets, the Kuiper belt, the comets, the invisible shell surrounding the sun, the overlapping boundaries between stars, the dissolving edge of the solar system. After all of it, you are still here, standing on Earth, looking upward from the inside of something almost impossibly vast. Because no matter how enormous the Oort Cloud becomes in your imagination, there is one fact that remains emotionally difficult to process. Human beings discovered all of this without ever leaving the center of it. We uncovered the scale of the outer solar system while living on a tiny rocky planet buried deep inside the warm inner fraction of the sun's domain. That alone feels almost impossible. Imagine ancient humans standing beneath the night sky thousands of years ago. No telescopes, no physics, no knowledge of galaxies or gravity. Only darkness above them filled with silent stars. To them, the sky probably felt close, manageable, a dome surrounding the Earth. And yet hidden inside that darkness was a structure extending trillions upon trillions of miles outward into interstellar space. A structure humanity would not even begin understanding until extremely recently. For almost all of human existence, the Oort Cloud was already there. Silent, invisible, surrounding the solar system in every direction, while civilizations rose and collapsed beneath it. Empires disappeared. Languages evolved. Entire religions formed and faded. And through all of it, frozen objects continued orbiting slowly at the edge of the sun's influence, completing journeys so long that human history itself became only a tiny moment inside them. There is something haunting about that. Not frightening exactly, just deeply humbling. Because the Oort Cloud exists on timescales that make human civilization feel temporary in a way most people never emotionally confront. A comet beginning its fall toward the sun today may not reach the inner solar system until long after modern civilization has changed completely. Some already moving inward may have started their journey before the first pyramids were built. Others may have begun falling toward the sun before humans even existed. Right now, ancient objects from the edge of the solar system are traveling silently through darkness toward a future Earth they will never recognize. And at the same time, Voyager continues moving outward, still carrying human fingerprints into the deep outer system. A machine built by beings who evolved on a world orbiting a star they barely understood until recently. There is something poetic about that symmetry. Comets falling inward, Voyager moving outward, one carrying the memory of the solar system's birth, the other carrying evidence that intelligence briefly emerged near its center. And somewhere between those two motions, there is us, watching, trying to understand, trying to place ourselves inside a structure far larger than instinct can comfortably accept. Maybe that is why space feels emotional, even when it contains almost nothing alive. Because space forces humans to confront scale honestly. No distractions, no illusions of importance created by everyday life. Just reality stripped down to distance, time, motion, and silence. And silence dominates the outer solar system. That may be the most accurate word for it. Silent, not emptiness, not death. Silent. The kind of silence so complete that even sunlight begins losing emotional meaning. Imagine drifting near the outer edge of the Oort Cloud. No nearby planets. No visible civilization. No warm sunlight touching your surroundings. Only stars in every direction. And among them, one slightly brighter point. The sun, home reduced to a star. Earth reduced to invisibility. Human history reduced to something smaller than dust against cosmic distance. And yet, strangely, that realization does not make humanity meaningless. If anything, it makes consciousness feel more extraordinary. Because inside this enormous silent structure, matter organized itself into living beings capable of understanding the structure surrounding them. The universe became aware of its own scale through minds evolving on a tiny world hidden deep inside the inner solar system. That is astonishing. Not because humans are the center of reality, but because reality produced creatures capable of questioning it, capable of imagining distances they will never physically travel, capable of discovering invisible structures extending halfway toward another star. And perhaps that is the true emotional core of this entire journey. The Oort Cloud is not important because humans will someday colonize it. Most of it is probably too distant, too cold, and too empty to ever become meaningful in an ordinary human sense. It matters because it changes perspective. It forces the mind outward, past Earth, past the planets, past ordinary intuition, until finally the universe stops feeling like a collection of nearby objects and starts feeling like one continuous structure unfolding across impossible scales. That transformation changes people. Once you truly understand the scale of the solar system, normal diagrams begin feeling strangely incomplete. The old image disappears forever. The neat rows of planets orbiting close to the Sun no longer feel like the real picture. Now you know what surrounds them. Darkness stretching outward for distances so extreme that the nearest stars begin feeling close by comparison. And somewhere inside that darkness drift trillions of frozen remnants from the birth of the solar system itself. Ancient ice older than Earth's civilizations. Older than human memory. Older than humanity. Still orbiting. Still preserved. Still moving silently through interstellar night. The strange thing is, most people will live their entire lives without ever thinking about that, without realizing how large the solar system truly is. And maybe that is understandable. Human life happens locally. People worry about days, bills, families, cities, survival. The human brain evolved for immediate reality, not for processing structures measured in light years. But every once in a while, astronomy pulls the mind outward beyond those ordinary scales. And for a brief moment, people see where they actually are. Not at the center of reality, not inside a small planetary system, but inside a vast gravitational environment embedded within an even larger galaxy. A galaxy containing hundreds of billions of stars, each potentially surrounded by their own distant invisible clouds fading into interstellar space. And suddenly the night sky changes. The stars stop feeling flat. Space stops feeling empty. Everything gains depth. History gains context. Humanity becomes part of something larger instead of separate from it. Maybe that is why people have always looked upward. Even before science. Even before astronomy. Something about the night sky instinctively tells humans there is more beyond immediate experience. The Oort Cloud is one expression of that more. A reminder that reality continues far beyond the visible edge. Far beyond instinct. Far beyond the comforting boundaries humans naturally create. And maybe the most beautiful part is this. The universe did not hide these truths completely. The evidence was always there. In the comets crossing ancient skies. In the strange trajectories pointing outward into darkness. In the mathematics of gravity. In the motion of objects humanity slowly learned to track and understand. Piece by piece, generation after generation, humans reconstructed the invisible architecture surrounding their world. Not because it was easy, but because curiosity kept pushing farther outward. And that curiosity may ultimately matter more than certainty itself. Because the universe always appears larger after every discovery. The edge keeps moving. First beyond Earth, then beyond the planets, then beyond the heliosphere, then beyond the visible boundaries of the solar system itself. Every time humanity thinks it understands the scale of reality, another larger layer appears beyond it. And maybe that process never truly ends. Maybe the universe is not something with a final edge waiting to be reached. Maybe it is something that continually expands intellectually as consciousness pushes farther into it. The Oort Cloud feels important because it represents one of those expansions. A moment when humanity realized home was vastly larger than expected. And perhaps one day, future civilizations will look back at our understanding the same way we look back at ancient skywatchers, as only the beginning. Because there are probably structures beyond our current imagination too. Larger patterns, deeper connections, more hidden layers waiting in darkness. But for now, this is where we stand. On a small world orbiting an ordinary star. Inside a solar system that does not truly end. Surrounded by an invisible frontier of ancient ice fading gradually into the Milky Way itself. And somewhere above Earth tonight, beyond the planets, beyond Pluto, beyond Voyager, beyond the last fading traces of sunlight, the Oort Cloud is still there. Silent, dark, enormous beyond intuition. Wrapping the solar system in a sphere so vast that human civilization has barely begun to emotionally comprehend it. And maybe that is the final realization this journey leaves behind. The universe is not only larger than we imagined. It is larger than we are naturally capable of imagining. Yet somehow, we keep trying anyway.